Welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're going to be talking about route maps with tags and what advantages it provides to your network. Before we get into the lab, let's get inside the details. A route map is a tool on Cisco devices that uses if-then logic for network policies. You can use it to match on any different items such as access lists, BGP AS path lists, BGP communities, interfaces, packet length, routing protocol metrics, and more. Optionally, you can then set a value such as an output interface, routing protocol metric, BGP attribute, tag, and more. Alright, so let's talk about key points. Route maps process statements sequentially from top to bottom, stopping at the first match. Each statement can be permit or denied with optional match and set commands. An empty route map statement, no match condition, matches everything. Route maps end with an invisible implicit deny similar to access lists. Match conditions include prefix lists, access lists, BGP attributes, packet length, and more. Set commands change values like metrics, next swap addresses, BGP attributes, and DA's CP values. Multiple match conditions in one statement work as a logical OR. Multiple set commands can be configured in a single statement. So let's talk about now tags inside route maps. Route map tags are a numerical identifier assigned to route within a routing protocol. They are used as a condition to permit or deny redistribution of routes, prevent routing loops, and filter routes based on specific criteria. A set tag command adds a numerical tag to a route, while a match tag command within a route map can check for a specific tag to apply other actions. So how route map tags work? Assigning a tag. A set tag number command is used within a route map to assign a numerical tag to a route that matches the clause. Matching a tag. A match tag number command is used in a separated clause of a route map to identify routes that have been assigned a specific tag. Preventing loops. Tags are specifically useful in route redistribution scenarios to prevent loops. For example, a route map can be configured to deny routes with a specific tag from being redistributed back into the original routing protocol. Filtering and manipulation. Tags can be used to filter and manipulate routes. For example, you can set a tag on a specific route and then use a separated route map to deny any routes with the tag from being advertised to a particular destination. Alright, so let me break it down to you. The first thing we're going to do is we're going to configure router number 1. We're going to configure Ethernet 0/0 with the corresponding one IP address. We're also going to have two LANs, which are going to be configured on loopbacks. And we're also going to be using OSPF as the routing protocol and the area 0. Let's move on to router number 2. In here, we're going to be configuring Ethernet 0/0, 0/1, and 0/2 with the corresponding one IP addresses. We're also going to configure a loopback, which is going to simulate the LAN on router number 2. And keep in mind that every single route that comes from OSPF, I'm going to be assigning a tag of 777. And what we want to accomplish in this scenario is to inject routes with tag 777 to router number 3, but not router number 4. Alright, so this is the CLI we're going to be applying to router number 1, router number 2, router number 3, and router number 4. I'm going to leave these commands for a couple of seconds. You can always go ahead and pause the video, take notes, and remember, practice makes perfection. Now that we have finished covering up the details about route maps and tags, let's go inside CML now and let's get started with the lab. Let's get it, guys. Alright, so we're inside CML now. We're going to start configuring router number 1 with the loopbacks and the one interface with the corresponding IP addresses, and also we're going to configure OSPF as a routing protocol. Let's get started. Alright, so we completed the configuration on router number 1. Let's go ahead and jump into router number 2. Let's configure the loopback, which is going to be emulating the LAN. And we're also going to configure Ethernet 0/0, which is going to be the WAN pointing out to router number 1 with the corresponding IP address. And we're also going to configure OSPF as well. Some days I just can't type. Alright, let's just wait until the OSPF adjacency comes up and we're good. Let's check out now the IP route and just verify that we have the routes being ejected from OSPF on our neighbor router number 1. And we're good, we're solid. Now we're going to proceed and we're going to configure Ethernet 0/1 and 0/2 with the corresponding IP address. And we're also going to configure EIGRP, which is going to be the routing protocol that is going to be used to form adjacency from router number 3 and router number 4 towards router number 2. As you can see, the 172.16 network, I'm only advertising that via EIGRP 90, which is going to be advertised to router number 3 and router number 4. And keep in mind, router number 1 is going to know about this network once we start with a redistribution between routing protocols. Alright, let's jump into router number 3. We're going to configure one interface with the corresponding IP address, which is going to be Ethernet 0/1. And we're also going to configure routing protocol EIGRP as well. Alright, let's wait for EIGRP adjacency to come up. We're good. Alright, let's do a show IP route. We should be getting the 172.16 network, and we do. Awesome. Alright, let's jump into router number 4. We're going to configure one interface 0/2 with the corresponding IP address, and we're also going to be configuring EIGRP as well. Alright, let's wait for EIGRP adjacency to come up. We're good. And let's also do a show IP route. And let's verify we got the 172.16 network, and we do. Awesome. Alright, so let's jump back into router number 2. We're going to start configuring the route map called OSPF to EIGRP, which is going to be responsible for tagging every single route that comes from the OSPF domain towards the EIGRP domain with a tag of 777. Alright, so let's jump back into router EIGRP 90. We're going to do a redistribute OSPF 1. And we're going to apply the route map that we created to tag all the routes that come from the OSPF domain towards the EIGRP domain with a 777. We're also going to be redistributing EIGRP into the OSPF domain without no filters for now. Alright, so let's do our show IP EIGRP topology 10.100.1.1/32, and as you can see, we got an administrator tag of 777 at the end. Let's jump back into router number 3 and let's do a show IP route, and we got the two routes coming from the OSPF domain. Awesome. Let's jump into router number 4. Let's do a show IP route, and as you can see, both routes are there as well. Awesome. Alright, so let's jump back into router number 2, and we're going to create two route maps now. We're going to create a route map to block tag 777, and we're going to allow the rest, and we're also going to permit tag 777 and allow the rest as well. Alright, this first route map is going to deny tag 777 towards the EIGRP neighbor that we're going to just apply it to in a few minutes here. This is the one that's going to permit everything else, and we're also going to create another one that says permit tag 777 permit 10, which is going to allow tag 777, and we're also going to configure another one that says permit 20, which is going to permit everything else that is not related to the tag 777. Let's go inside router EIGRP 90, and we're going to type the command distribute list route map permit dash tag 777 out of Ethernet 0/1, and we're also going to put distribute list route map block dash tag 777 out of Ethernet 0/2. Alright, so let's go to router number 3. Let's do a show IP route, and as you can see, the routes coming from the OSPF domain are still present. Let's go jump back into router number 4 and let's do a show IP route, and as you can see, I am no longer receiving routes from the OSPF domain. Let's do a ping test, and as you can see, it's not responding, but I'm going to show you a flaw that this setup has. I'm going to add a default route on this router pointing to router number 2, and you're going to see that afterwards I'm going to be able to ping 10.100.1.1. Let's go to router number 1. Let's do a show IP route pipe include 192.168.3.0, and as you can see, I got it in my routing table. And the reason being is that, remember that I redistribute EIGRP into OSPF domain with no filters. To overcome this issue, we're going to go to router number 2, and we're first going to create a new prefix list with the 192.168.3.0/30 network, and we're going to name that prefix list EIGRP-2-OSPF. We're going to create a new route map, and we're going to reuse the same name as the prefix list, EIGRP-2-OSPF, deny 10, and we're going to match that new prefix list that we created. And we're also going to add another route map statement with a permit 20, and this is going to permit everything else. Let's go now to router OSPF 1, and let's do the same command, redistribute EIGRP 90 route map EIGRP-2-OSPF subnets. Alright, let's go to router number 1. Let's do a show IP route pipe include 192.168.3.0, and as you can see, the route is no longer available. Let's go to router number 4. Let's do a ping test again to the 10.100.1.1, and as you can see, it requests timeout. You might need to add some extra layer of security. Keep in mind that. This is gonna be all for today's video. I hope you enjoyed the content. If you did, please give it a like, and as always, this is Julio. I'll see you in the next one. Peace out.